Hello, right, day 7 of Maker Advent, and what do we got today? Well, we've got day 4 of the Pi Hut's Maker Advent Calendar with the Pico H. And we have Banana for Scale. Banana for Scale will be retiring today. Unfortunately, it has developed a split on the back, as we can see there. So it'll be retiring and it'll be going into a porridge tomorrow morning. Thank you for your service. Anyway, back to serious stuff. Opening boxes every day. So, day 4, I've also learned, remember, how to open these boxes. There we go. And inside today, pop that down there, we have a plastic bag with a potentiometer and some wires and a knob. So, more wires and a potentiometer. Does it say on the back which one it is? Oh, it says on the front. There we go. It is a B10K. Bjork. It's Bjork's. No, it's not. It's a 10K potentiometer. So it means that the resistance changes as we turn this knob. Let's get it in shot. There you go. Turn that. Resistance changes from 0 to 10K. So this is an analog input. This is old school electronics. So with this we can alter the currents going through a circuit and we can make LEDs fade in and out. So we're going to use this because I've read ahead to control the input on the Pico on pin 27, and we're going to read that pin, which is an analog pin, to control the brightness of these LEDs using something called pulse width modulation, PWM, which really means turning a switch on and off really fast. So we're going to turn a GPIO pin on and off really fast for these LEDs. You know when you were a kid and you went into a room and you turned the light on really quickly, light switch, flick it on and off really quick? That annoying thing? That's PWM. It's also annoying for your parents anyway. I had great fun doing it. So what I'm going to do now is build up this circuit, put some test code on, and we're going to have a play. So, one moment please. Okay, I'm back and we have the circuit built. Simple circuit. I'm reusing the breadboard from the previous day. I've took the buttons out and all the wires. I've removed the 3-volt connection which goes to the breadboard. We're now connecting this potentiometer directly to 3V3, 3V. And we're using, let's see, it is GPIO 27, which is an analog input pin. So what happens is we've got power and ground going into here, and we turn this knob and the resistance changes. As the resistance changes, it sends a signal to the analog input on the Pico, which is read by the Python code, which then tells the LEDs to dim or go brighter. Okay, so we've got a circuit built. We need some code to make it run. So we're going to go into Phony now, and we're going to look at the code. This is example code from the Pi Hut for day 4. They've got loads of example code, in fact. Let's go to that first of all. We can have a good look. So it shows you how to, well, what's in the box. Another Brad Pitt joke there. I haven't watched 7 for years. Might watch it again soon. What a great Christmas film that is. So it tells us what a potentiometer is. It tells us how to construct the circuit. So we're taking the bits and pieces out and going back to day 2, if I remember correctly. Using the breadboard from day 3. And that little thing that looks like a tyre on the breadboard is a potentiometer. That's how it looks in Fritzing, which is what they've been using for the illustrations. It shows how to wire it up. So the red wire is going to 3 volts, the black wire is ground, and the purple wire is the analog output. So it's the output from potentiometer going to the analog input on the Pico. The first task I suggest is just printing the analog value. That is the right thing to do first of all. It checks that your hardware is working and your software, your code, is working correctly. When you've got that down, you can move on to the more exciting stuff. But I'm skipping all the way to activity 4. LED fader using PWM, so pulse width modulation, what I mentioned before, the light switch that annoys your parents. We're going to use that, and the example code here, which I've adapted slightly because I want to use all the LEDs. Here we're just using one LED on pin 18. So let's go to the Phony code. There it is. Now I'll go to Phony as well. Okay, so we start off as normal. We have 2 imports. So from machine, so that's the way we can use GPIO, import ADC, analog to digital conversion, pin, GPIO pins, and PWM, pulse width modulation. So all 3 of those allow us to use the GPIO, the analog inputs, and to have the digital pins to be PWM. We then say, okay, got a potentiometer. It's on pin 27 and use the ADC to read it, so analog digital converter. So when we turn the knob, it's going to spit out a lot of values which the the Pico will understand. Same objects as before, red, amber, green, on pin 18 and pin 19, pin 20. In fact, I've got a typo there. I don't need pin out, I can get rid of that. So let's delete that typo. And I've just tested it and it works, but let's get this right. There we go. So red, amber, green, pin 18, pin 19, pin 20. But notice we've now got a function called PWM, which is saying set those pins up as pulse width modulation pins. Remember kids, check your code. Bingo. So we then set the frequency for PWM. So this is how often the switch will power up between on and off. 1000 hertz, that'll do. We're going to create an object, a variable to store the reading. So right now we're going to say, right, reading is 0. It's got nothing in it. That's what it is. While true, run forever. So the reading, so the actual reading from the analog input is we read a potentiometer connected to GPIO 27, and then we store it as reading. We then print that to the Python shell, which is this thing down here. And then set the duty cycle, so how often it turns on and off, using the value of reading, which is our variable, which is reading the potentiometer. And we then sleep for a really short amount of time. And that's it. That's the code. That's PWM. So I'm going to save this now. So that's saved to the Pico directly. I'm going to click on run. So you'll see loads of values spitting across the screen there. As I change the potentiometer, so turn it up and down, you'll see those numbers change. You'll also see down here, hello, the LEDs get brighter. There we go. So we have LEDs controlled using PWM and analog input. So that's day 4 done. We've done analog inputs and PWM outputs. That's it for today. See you later.